Okay, so I've just loaded my NetBeans. Let's have a look at implementing this in practice. Well, there's the three steps. Let's go through those again. We have the declaration of the number of fingers. Then it starts off at 0. So initially there are 0 fingers up. And you'll notice we have a semicolon here. There's a good rule of thumb for semicolons, which is to always put a semicolon at the end of the line, unless the next line has a curly bracer on it. An opening curly bracer. So that's one of those things up there. So if the next line doesn't have a curly bracer, stick a semicolon in. The second thing we wanted, which was when we reach 10 fingers, stop. So keep going while the number of fingers is less than 10. And then we look on the next line, we go, is there a curly bracer? There is no curly bracer. That's not an opening one anyway. So there's a semicolon. Now we need to go have our increment. So we say, okay, well, here's how you increment your number of fingers. You have the number of fingers equals, well, one more than before. So before there was number of fingers. Now one more of those means plus 1. Now I'm going to leave a semicolon here just because I want to show you the full working. So the rule I've just taught you says if there's no opening curly bracer on the next line, stick a semicolon in. So that's right as far as we're concerned now. Now we need that 4-bit, which we learned, 4, and the closing curly bracket here and the opening curly braces below. So I will go put that in. There's the 4 open brackets. Now you'll see there that was autocomplete. So I typed FOR and open round brackets, and it immediately put a close one in. So you have to watch out for that and press delete, because that's not how we want to format it. So let's put in the closing round bracket and curly bracer and a closing curly bracer. So I pressed enter and it immediately put a closing curly bracer in. So you have to watch out for autocomplete. Now we've just gone and broken one of our rules because we've got a semicolon here and the next line has an opening curly bracer. So that means we have to delete it. So we never have a semicolon when the next line has an opening curly bracer. So that's a good rule of thumb there. So let's see what happens when we run this. So at the moment we're repeating, but there's nothing in the curly braces. So we should repeat nothing. Excellent. Nothing is happening. So let's try moving Pac-Man forwards. So here we have the number of times to repeat is effectively this. Say repeat 10 times. That's a good way of thinking about this. And here's the thing we're repeating, the move. So let's see if this works. Well, it says he has taken 10 steps, so we know he has moved 10 times. Let's see if we can gain a bit more insight into this. So I'm going to use main.send message, because we know send message can be used for displaying variables. So I'm going to put in here number of fingers. So what should happen now? Always have a think about what's going to happen before you run it, and then confirm by running it what you thought was going to happen. So here's where we say number of fingers is 0 to start with, and this only happens once. It then says, okay, are there less than 10 fingers raised currently? No, we're at 0 because we just started. And then it'll actually carry this out and it will display the number of fingers on the screen, and then it will move. Pac-Man will move forward. Then it gets to the ending curly bracer, and at this point it will check and it will do this line here. So it's a bit kind of topsy-turvy, the ordering, but as long as you remember these are the 3 components here, you should be okay. It'll say, okay, do I have less than 10? Yes. So increment by 1. So the increment happens, we now have 1 finger up. And it goes, yes, 1 is less than 10. So now we go through again and we display the message, and then we move, And then we say increment by 1, so we now have 2 fingers raised. We've now moved twice. And is 2 less than 10? Yes, it is. So do it again. Display this message. Move. So we should see him move and a message appear. Move, message appear, move, message appear. Well, let's have a check, see if that's what happens. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you see that corner there? This is the number of fingers that are raised, and it goes up to 9. See that again? Counts. So given the frame rate on this video, it may be a bit jerky, but as long as you do this in practice, you should see how it moves. So we can see that the number of fingers does actually increase by 1 each time. It's not some sort of magic mystery here. We really have to teach everything to a computer program. We have to teach it how to increase by 1, for goodness sake. So let's say we teach it to increase, let's say, check less than 5. So if I change this to 5, it should say, okay, well, start off at 0, and then each time you've done your action, raise 1 finger, as long as there are less than 5 fingers raised. So that should be 5 times he moves. Oh, well, he moves 5 times. Now, the reason you'll only see 4 here instead of 5 is because we're starting at 0. So we have 0 fingers, we move, then we raise 1. And then we say 1 is less than 5. And once we've on our 4th loop, he moves, then we end up with the number of fingers raised being increased to 5. And we say, is 5 less than 5? Well, 5 isn't less than 5, 5 is 5. Therefore, we stop. So you'll never see the 5 appearing. So you always start off at 0 and you go up to less than the 5 here, you see. And it'll actually never display the 5 there. So try it out for yourself if you like. If you start off counting at 1 and then you count less than 6, it will start counting at 1 and it should count all the way up to 6. There we go. It starts at 1 and counts up to 5. So usually we will start off at 0, though, because that's just the way we kind of do things. And if you're in any doubt about what a for loop does, just look at it and go, what's the number here? Because 9 times out of 10, the for loop that you are facing with will start at 0, its increment will be 1, and the condition will be less than a number. And you just look at that and you go, okay, that's the number of times it's going to do the thing in the curly brackets. What's the thing in the curly brackets? It's moving. So let's see if we can make him go round in a circle. So going round in a circle means moving up 4, turning right, moving forward 4, turning right, moving forward 4, let's say. So up, right, down, left. So we're going to have to do something 4 times, because there are 4 sides. And the thing we're going to do is move forward 3 times and then turn right. Now I'm going to switch this to the blank map because that's a nice easy example. So hopefully he should move in a nice big square. So he's done that. Why did he do that? Well, he moved up 2 and he turned right. That's the action. Moved up 3, sorry. That's the action. This is the thing to repeat. This is the number of times to repeat it. Okay, you can also, let's say, embed these. So let's say we want to have instead of moving 3 times, we want to move 10 times. Well, the option would be either we copy and paste this and go paste, paste, paste. Okay. close this. Okay, so here you should be moving 10 and turn right and then move 10, then turn right and move 10. So that's one option. The other option is to do what we call nesting. And nesting is when we have one inside the other, a for loop inside a for loop. So this is the thing we want to repeat. I'm just going to put in a comment here, end thing to repeat, and this is start thing to repeat, and number of times to repeat is 10, so we'll delete that because we now know that we're going to replace it 10 times. So let's copy our for loop, and I'm just going to paste it directly under this comment, and then the end also needs a curly bracer, so there's the end. Now you can see there's a couple of problems. The first one, we've gotten messed up our nice structure. So the one way we can get around this is to go down to format, and that will move things in nicely for us, sometimes less than others. I like it to look a bit like that actually. So the amount of indentation we have it matters, because it doesn't matter in terms of programming, but it matters for the visual eye. So we can see this is the moved in, this moves in by 1, so there's indentation. That means this thing is being repeated, and this is indented even further, which means this is happening more often than this is happening. That's what that effectively means. You'll figure it out as you go along, but if you end up with everything all over the place, you could just right click and hit format and see if that improves things at all. So there's now an issue here. It says number of fingers is already defined. So if you see this message, it means I'm starting counting, and when I get to 4, I want to stop. That's what the first for loop here says. The second for loop says, hey, I also want you to start counting at 0 and go to 4. Now, they can't both count in the same hand. That's a problem. So let's go with number of fingers on. Let's go with calling this number of fingers on other hand. So number of fingers on other hand is 0. Number of fingers on other hand, as long as it's less than 4, increase the number of fingers on your other hand by 1. And this is a practice you're going to have to get into the habit of doing if you're nesting these, if you're having one inside the other. And that is to use a different variable name for this one and this one, because they can't both count using the same variable. Otherwise they'd overwrite each other, and it would cause horrible problems. So let's run this. So he's now moving 4. Why is he moving 4? Because the inside here is 4. So we wanted this to be 10. So we're going to have to change this here to 10. That's a little bug there. So now we're saying, okay, I want you to do the following 4 times. Move 10 squares and then turn right, because all this is the equivalent of move 10 squares. Okay, so here we have him moving 10, turns right, moves 10, turns right, moves 10. So hopefully this has given you all the skills you'll need to solve this entire map in about 20 lines of code, maybe about 40 lines of code. So you can actually solve this entire map with about 40 lines of code. And in fact, you'll only have 2 or 3 for loops and some move statements and things. I'll let you guys work that out on your own though.